Hello, I'm Channa Bankapur. I'm going to discuss my solution to the LeetCode problem, populating next right pointers in each node. It's today's daily challenge in LeetCode. The problem definition is as follows. We have a perfect binary tree. It's also called fully complete binary tree, where all the leaves are on the same level and every parent has two children. Um, in other words, every level is full, even the last level. So obviously all the leaves are going to be in the last level in that case. So normally a binary tree has only left and right children. So this is how a perfect binary tree looks like. So all the levels are full. And we have one extra pointer in every node called next pointer. And this is what that needs to be done. So where in every level, the node should point to the next node in that same level, right? So that's how it is should be pointing to. Obviously, the last node should point to null, right? And it's only within the level. This is what we need to do. It's not a very hard problem in that sense, because if you do a BFS traversal, so normally we do it this way, right? So we go level by level and from left to right. So whenever you're processing a node, so let keep track of the previous node in that level and let previous node point to the current node. So that's how we can always make it. And finally, the last current node does not have to point to anything because it is already initialized to null, right? So if you do it that way, that's going to be very simple. So we can use what's called breadth first search, where at every level you can start a new loop and make sure the previous node points to the current node, right? So that's the idea here. All right. Let me show you the code. It's not that hard to understand. So I'm using a queue for BFS here. So queue is initialized with the root node pushing into the queue, and here look at this. I'm finding the length of the queue at the moment because this is for each level. So this while loop runs for every level. So previous node is going to be pointing to null to start with because the first node does not have a previous node, and current node is going to be from the queue, and so I'm going to push these into the queue based on the current node, whether the left of the current node exists or not, and right of the current node exists or not. And this is the key point here. If previous node is not null, that means this is not the first node. So then previous is going to point to current node, right? So this is going to set those next pointers, right? So I'll update the previous pointer to current node, and that's how the whole level is going to be set. All right. So this is just for the level, and then we go back to the while loop, which is going to do the same thing for the next level until there is one last level. All right. So this should work. Let me just compile and run. Right, it's accepted. So this works with the same time complexity as the breadth first search, so which is linear in this case because it just every node is going to go to the queue and then it is enqueued into the queue and dequeued from the queue only once, and that is very clear to see that it works with linear time with respect to the number of nodes in the tree. Right. So if there is any other way of implementing this one, please let me know. Please like the video and subscribe to the channel. Thanks for watching. Keep coding.